Yeah, good evening. Today we will discuss like week 11 concepts and questions. Yeah, if you have any doubts from AQ or PQ, you can ask. If not, we'll go one by one. Oh, okay, I assume like we have no doubts, but we'll go like PQ questions one by one. First of week 11 PQ. I am audible, right?
Yes, ma'am.
Oh, yeah. Yeah, thanks. Uh, so yeah, and now here we have two threads. These two threads, PRL sequence 1 and PRL sequence 2. Yeah, and we are starting those. What happens if we start those threads? They will execute the run methods. No, yeah, but yeah, just a minute. Yeah, if you have two threads T1 and T2, previously we have also seen the order of execution. No, if it has state S1 and S2, that means statement 1 and statement 2, we doesn't know like which order it follows, whether yeah. Uh, Whether T1 executes first or T2 executes first, we don't know. So what we will say is like they executes the output in an interleaved manner. Both the threads execute concurrently. Here the th1 and th2 executes concurrently, and they executes in an interleaved manner. We can't predict in which manner they are going to what execute. Okay, order is unpredictable. Yeah, now what they will execute, they will execute the statements in the run method. So you know what are the statements which are present in the run method of th1 and th2. So th1 is a thread of prl sequence 1, and th2 is a thread of prl sequence 2. So okay, what are the statements here inside the run method? We're just printing. Here, see, you can see here just printing 11 to 20, right? The for loop is iterating from 11 to 20. No, yeah. Okay, in between we are checking whether the thread is interrupted. If it is interrupted, we are breaking out that we are breaking from this for loop. That means yeah, this thread will terminate. Okay, yeah. Here in the th in this thread to th2, the for loop is going from 21 to 30. 21 to 30. So what we are doing, we are printing the numbers, and we are checking whether the number is 25. If I is 25, then we are saying other dot interrupt we are calling. No, what is other is, here you can see, other is nothing but th1 only. No, what is the argument which we are giving is 3h1. So other is th1, that means th1 dot interrupt. What does the interrupt method will do? It will suspend the thread. If I say th1 dot interrupt, if I say th1 dot interrupt, that means the thread th1 is getting interrupted. It will it got interrupted, that means it got interrupted. Okay, that's all. Okay, now so here, so actually 11 to 20 and 21 to 30. From 11 to 20 first th1 is running, and 21 to 30 th2 is running. If it is 25, if th2 is encounters a value of 25, then it calls th1 dot interrupt. Okay, if it has seen interrupt, if if the thread th1 is interrupted, like in between it is also checking. No, the for loop it is checking, right? If the thread is interrupted, then we will break out of the loop. That's all. If the thread is interrupted, then we are coming out of the loop. That means this run method is terminated, the thread execution has finished. Okay, till when they will print the values in an interleaved fashion? Till the th1 thread got interrupted, they will print, these two threads will print the statements, this 11, 12, 13. Let's say if first thread is executing for the first time, okay, 11, the output will be 11. In the second time, if thread 2 is executing, it will be 21. Similarly 12, if it is 22. Yeah, similar. The order is unpredictable, but the thing is like they will print the output, this I value, in an interleaved in an interleaved manner until I equal to 25. If I has become 25 in thread 2, that means the thread will get interrupted and will this what execution will be finished. That's all. And okay, okay, while the thread is getting interrupted, while this thread has interrupted, while this thread, the first thread has got interrupted, if it has encountered this sleep statement, at that time it will say catch, at that time it will get interrupted exception. No, if the thread is sleeping, if we are calling interrupt method on that thread, we will get the interrupt exception, because the thread is sleeping, it is not doing any work, but we are trying to interrupt the thread. So at that time you will get the interrupted exception. So at that time also the thread will what stop execution. Okay, if the thread is here and if it has encountered interrupt statement, then it will simply break means it will come out of the loop, the termination will finish. But if the thread is somewhere here, if the thread is somewhere here, okay, while it has encountered interrupt statement in the thread 2, if it is somewhere here, it will just print this whatever the value. Let's say if it is 16, while it was iterating, it will print 16 and it will just sleep. And then like while it is sleeping, it will get interrupted exception. No, yeah, that's all. So anyhow, the thread will terminate after the T2 has encountered the value of 25. Until then, all the values will be printed in like all the values will be outputted in an interleaved manner. That's all. Okay, you can see the options and you can tell like you can just see the options and you can tell why this is incorrect or why first option is incorrect and second option is incorrect. We can discuss. Anyone want to tell why this is incorrect? First option, why first option is incorrect? Anyone of you?
It happens parallelly, so it will come interleaved.
Sorry, can you be
It will
bit
happen together, right? Both the threads are running parallelly.
yeah,
You should not finish one and then, I mean, they're running together.
yeah, that means interleaved means that only, like they are running, like output is like thread 1 and thread 2 are running parallelly, output is interleaved means like they are running simultaneously
Oh, yeah,
only.
so we're not checking for that condition of thread 2 being 25.
Yeah, yeah. So if thread 2 is 25, we are just thread 1 is getting terminated till thread 2 has reached encountered the value of 25. Till that time only we are printing thread 1 and thread 2 are printing the values in an interleaved manner, right? Yeah, so this is like we are not checking for 25 condition. That's case. And why this is okay, here there is no interleaving. That means like here the output is in the second option, the thread th1 prints 11 to 21st and followed by thread 2 th2 is printing 21 to 30. That means we are saying 11 to 20 will be printed first and then 21 to 30 is printing. That is not the case. No, they both will be printed. Thread 1 and thread 2 are happening simultaneously, so output we will get in an interleaved in an interleaved way, and we cannot predict that output. Yeah, so this option is incorrect because it is not mentioned interleaved or anything. No, yeah. Why this is incorrect? Third option, the thread th1 and thread th2 initially may print the numbers in an interleaved manner, okay, in an interleaved way. However, the thread th2 gets terminated after printing 25. Here, which thread is getting terminated? Whether th1 is getting terminated or th2 is getting terminated. You can see, which one is getting terminated, th1 or th2?
H1.
Yeah, th1. So this is kind of incorrect only, that So this is this statement is incorrect. Okay, the thread th1 and thread th2 initially may print the numbers in an interleaved way. Okay, they are printing the numbers in an interleaved way, whatever we have discussed. However, the thread th2 after printing 25, okay, thread th2 after printing 25 causes the thread th1 to terminate. This is correct, no? Okay, yeah, this is correct, right? You can see the question once more, just the question once more, and then we can move to the other question. Like now you know, right? Now what is happening actually in this threads in this question. So you just see this. If you have doubt, you can ask, or else we'll move to the next question.
Ma'am, option 2, that could
Sorry,
also be right now. I mean,
which
it can also
option?
print option 2.
Option 2.
Because first it can not in a, I mean, that could be a possibility that this could happen, right?
Sorry, there could be.
Option,
Yeah,
yeah.
see what option 2 is telling. What option 2 is telling?
It's first prints thread 1 and then followed by thread 2.
Yeah, that is also possibility, but thread th1 is getting terminated, no, after seeing 25.
Yeah.
Yeah, so yeah, that is not mentioned here anywhere, no. Thread th1 is getting terminated. Yeah, so while, so let's take, okay, 11 12, okay, you are saying 13 14 15, okay, 11 to 20 will be printed first, and then followed by 21 to 30. At that time you won't see this case, no. 25, after seeing 25, anyhow thread th1 is terminated.
Yeah.
But actually what this option is telling is like, yeah, this is also possibility, yeah. But the thing is, like, always the output happens in an interleaved way only, right? Like as they are running parallelly, you will get an interleaved output only, basically. Yeah, that like,
But this could be also a possible outcome, right?
yeah, this is also like kind of possible. So yeah, Arup sir or Danya
Yeah,
ma'am,
can you go up little in the program notice?
yeah. uh, so actually, sir, she is telling like, okay, while thread 2 is seeing 25, then only this thread 1 is getting terminated. But what happens if thread 1 has finished its output first? If thread 1 has printed all the values like 11 to 20, and then if thread 2 execution has started, at that time we will get 11 to 20 and then 21 to 30. Anyhow, after reaching 25, thread 1 is already terminated, and yeah, at that time, like, she's telling like this is also one of the possible way, you know, something like that.
So what the claim is like, is the option 1 is also correct, is what you're saying, or what
No,
is that?
option 2, ma'am. So she is telling like, okay, if thread 1 will,
No, just
okay,
hold on, just show the option 2. See what thread option 2 says is that thread th1 first prints 11 to 20 followed by thread th2, right? When that is one of the possibilities. By option 2, what it means is this is what the thread always does, right? See, if you say option 2 is correct, it means that thread th1 first prints 11 to 20 and followed by the thread th2 printing 21 to 30. If we say that that is the correct answer, then that means that is what is happening all the time, right? Which is not necessary. It is one of the possible options, but
yeah, that
it is
also
not the thing that happens all the time.
Okay, ma'am, I get it.
Got it, right? When we are saying the second option is correct, it means that it will always do this thing, right? I mean, that is the claim that the second option is making, right? That is one of the options. Yeah.
And
But that is not always.
one more doubt I have.
If we say that it may print, then
print,
if we say that it may print, then it is correct.
yeah.
It says that it prints, then it is something like the always prints. What is no the difference? Yeah.
Yeah, I get it.
Yeah,
But
if
ma'am,
you say it may something, if you include it may print
or something like that,
and
yeah.
then yeah, but you are saying that it exactly, you know. Okay, yeah.
What is your question? Next question, Joyce?
Next question is putting a sleep thread dot sleep that that sleep statement does it ensure that interleaving, like that's
No, sleep doesn't ensure anything. That is more for us to see the some. I mean, of course, certain times it does help, but most of the time you cannot depend on the sleep to ensure any kind of. You cannot enforce any kind of sequence by putting a sleep.
okay.
More like, when we want to see a particular output, sometimes when we put this 500 or 1000 or 2000, we see this output in a desired format. That's it. But beyond that, it does not enforce any sequence.
Okay, thank you.
One more thing, like see, whenever we are firing the interrupt, if the other thread is already dead, can we call a interrupt? Will not it result in a exception? Not sure, but I think it will give an exception. It will stop at that moment.
Yeah,
Like
sir,
after
it
25,
may, yeah,
this
it may
particular
give, yeah, sir, it
that
will
will
it
kill
give,
this thread, right? See, this other thread is already killed, right? It is not living now. So for with a dead thread, can we interrupt that? I cannot remember. We need to check. Possibly it basically stop the current thread also. So it will never go beyond 25 or 26. But we need to make sure. Let's check. Okay. Cannot remember it.
yeah, okay. Okay, now you can just look at the question here. Just we are creating object of cake operation and baker and consumer one. We are just creating those threads, creating those objects only. Yeah. It just I'm asking you to look this question. Okay, here we have created the object of cake operation and we have passed it to both baker and consumer. We have passed it to both of them, baker and consumer. So yeah, after creating the like when we are creating the object, then this constructor will get executed. No, so what we are doing in this constructor, so this obj we are making it as O. What is O? O is nothing but this cake. What? O is nothing but this cake operation object. Okay, that we have set to this obj, and thread producer equal to new thread of this. So we are creating a thread of producer. Okay, we are creating new thread producer equal to new thread of this. This is runnable, no? So we are passing this to this. So we are storing that in the variable, in the producer variable. So we have created a new thread and we have passed the object of this baker, whatever the object now which we are operating on. And then we are saying producer dot start. That means we are starting this thread. So what happens if we start this thread? This all things we are not doing in the main, we are doing in the constructor only, right? So what happens when we start this thread? Yeah. So the run method will get executed. So meanwhile, that main method also happening, main thread is also happening concurrently, so at that time there are possibilities that the consumer also, this consumer this constructor also can get executed, the consumer object also can get created. So same thing we are also doing, that cake operation object we are giving to this obj, and then we are creating the thread and we are starting this thread. So this run method will execute now. So inside the run method, we are just here inside the run method, inside this baker class, we are just making int cake number equal to 1, and while cake number is less than or equal to 2. So what is the pattern we are seeing here? Cake number is kind of count only, some kind of iterator only, right? We are checking, we are first initialize some count to 1, and then we are checking whether count is less than or equal to 2. Then we are calling some method, and then we are incrementing. This is kind of iterator variable only. This is just a iterator variable, this cake number. And inside this run method of the baker, we are calling make cake. So we are calling make cake inside this run method. obj.make cake, that is cake operation object, we are calling this make cake method. So this is synchronized. So as soon as this obj, this baker object, this baker thread, after what encountering this statement obj.make cake, this loop will get executed now after coming inside this synchronized block. So that means no other thread can execute this make cake, right? No other thread can execute this make cake, only baker can hold this make cake. Inside this make cake, you are just incrementing the cake count. This available cake count is initially 0, and then you are incrementing it, and then you are just printing a statement made 1 cake, cakes left is available, that is like 1 here. Okay, let us say at this time, okay, at this time, let us say consumer also, before make cake, if the consumer is executing eat cake, at the time available count is 0. At the after coming inside this loop, the available count will be -1, and it will print 8 1 cake, cakes left is -1. So it will print this statement. The thing is like, okay, the thing is like, after, if it has made 1 cake, if the what, if the baker has made 1 cake, so which of the following options are not possible outputs? So can we get this the output like this? Made 1 cakes, cakes left is 1. Made 1 cake, cakes left is 1. We cannot get, no. So this is synchronized, right? The block is synchronized. Make cake, that make cake block is synchronized. So after making cake, if the consumer has not consumed that cake, then your cake count will be 2, right? Even, yeah, your cake count will be 2. And yeah, the thing is like, after eating 1 cake, the cakes will be 0. Like if you have 1 cake, the cakes will be 0. But after eating 1 more cake, the cake count will be -1. This is because your this make cake and eat cake are synchronized. So like you won't get this kind of this data inconsistency, inconsistency, like available cake count is 0. So this is like kind of shared variable. Shared variable means the baker and also consumer is operating on this cake operation class simultaneously, and this available cake count is 0, right? This is shared variable. But what we are doing, this shared variable, we are keeping inside the synchronized block. That means only one thread can access this. So it will, if one thread is accessing this, it will complete all the statements which are present inside the synchronized block. Then only it will, the other thread will get chance, no. So yeah, this kind of output you cannot get like 1. So the output will be like 1 2 or something like that, but it won't be like 1 1, right? Is it clear? Or yeah, you can see this here, this output. Made 1 cake, cakes left is 1, and 8 1 cakes, here cakes left is 0. So that is like, after making 1 cake, if you have eaten 1 other cake, it will be 0. After making 1 cake, if you, the cakes will be 1. After eating, it will be 0. Okay, this is correct. Similarly, you can see all these are possible, but only the thing is, this is not possible. Is this clear? Because you have kept that code block in synchronized thing, that's why. So you won't execute this. So the thing is like, and so initially you will be in this run block, and your it will happen only 2 iterations, first and second. So So after encountering this make cake, this statement, like after finishing that make cake method only, then only the other iteration will start, right? So automatically your what, your make count, this cake count is always synchronized, this available cake count is always synchronized, so you won't get this kind of output. Okay, I think you should look this question once more, then if you have anything you can ask. uh, just try to figure out like why you are not getting 1100 some output like that, but why you,
Ma'am,
yeah.
Srinath here. What are the possibilities, ma'am? Like first you can make 2 cakes, then the customer will start eating after
Yeah, that are also, that is also possible.
then
First you
it will
can
reduce
make,
one by one.
yeah, you, yeah, first only the baker can start producing, that means cake count will be 2, it can happen only 2 iterations, no, so
So
it can
0 to 2
produce 2
directly. The baker can make it as 0 to 2 directly. Then
directly,
the customer will reduce
customer
it to a
can
1 by 1.
one, yeah, that is possibility. Yeah, or else it can make 1, it can eat 1, it can make 1, it can eat 1, or else without making anything the consumer itself can eat, so at that time output will be -1.
Ma'am, here I see that in the iterator of baker, the baker seems to be one ahead of the consumer always, like less than or equal to. So 2 iterations, while the
Here it is
consumer is only 1
starting,
iteration, like
no,
less
here
than
it
2.
is starting from 0, here it is
Okay,
starting
okay.
from 0.
So both are competing in the same level means it can, so it can become 0 also, no? There's a possibility like even if the baker cooks 2 cakes, the consumer can simultaneously make it as 0 also.
So baker, so baker is making the cake and consumer
Can finish it in the same speed as the baker bakes to reach 2 cakes. The consumer can also finish rapidly at the same pace and make it 0.
yeah,
Since the iteration is the same for
yes,
both of
yeah,
them.
yeah. That is also possible. Okay. Okay, we'll move to the other question. Okay, you can see this question. So here, just see the main method. You have created this bank object, bank, and then you have created the threads. And for this withdrawal class, you are passing the same object, bank object, same bank object for all this withdrawal class. Okay, we'll move to this withdrawal class. Just see this and tell. Okay, let me start. I will start this. So actually you have seen the thread T1, T1, sorry, T1, T2 and T3. T1 is thread of some same, like you are using new withdrawal here. That means new object for withdrawal. Here also new withdrawal. These 3 threads are operating on this withdrawal only. But what you are passing, the same bank you are passing for 3 withdrawal threads. We say passing same bank object for both, for three this withdrawal threads. So this bank object is obj, whatever, the same bank object. Name is different, no, every time name is sun, moon, earth. So name in the first thread it is sun and 20. In the first thread it is sun and 20. Here it is same bank object you are passing, same bank you are passing for withdrawal thread, and it is like moon, moon and 40. It is like earth and 80. Okay, that is the thing. So name and everything is different, but you are giving the same bank for withdrawal thread. Okay. So int total is 100. Here int is a shared variable between three threads or not? Any one of you? Is int a shared int total is a shared variable between the three threads? Whether T1, so if you update something on this total using T1 thread, will it get affected to this T2 and T3? Any one of you, please?
Yes,
Like you,
it's a shared variable.
yeah, it is shared variable because you are giving the same object, same bank object. No, that means this total is, this is the instance variable, and this instance variable total will be same for all these three object. Like as it is same object, you will, the value will be same for all the here in the all the three threads. Okay, now initially your total will be 100 for the all the three threads. Okay, now after seeing this, okay, you are starting this all the three threads. No, you don't know, the order is like unpredictable, whether T1 can execute first or T2 or T3 or anything. Anything can start first. Okay. So okay, let's take if T1 is starting first, then you will execute this run method on T1. So what you will say, bk is nothing but bank object. No, that object dot extract you are calling on this, you are calling the extract method using this name and money. Okay, name is T1. No, that means sun, and money will be 20. Sun and 20 here. Okay, now you are calling this extract method. If this is synchronized method, no, if T1 has entered this inside this extract method, then no other threads can call this. T2 or T3 cannot call this what, this extract method. See, cannot call, it cannot execute, they cannot execute this statements inside this extract method, because T1 has already occupied, T1 has already logged this extract method. That means it is like now only T1 can operate on this method, no other thread can execute this extract method. Okay, now sun and 20 you are passing, you are checking whether total is greater than withdrawal. Yeah, what is our total? 100 is greater than 20 years, 100 is greater than or equal to 20 years. So it will say, it will print the statement name, that is sun has withdrawn 20, and then you are saying total equal to total minus withdrawal, that is total will be 80. Now total is updated to 80. Will it get reflected in all these three in all these threads T1, T2 and T3, like whether total will be 80 only? No, for all the three threads now, because this is shared variable, as you are passing the same bank object to all the three threads. Whatever change you are doing in this variable, that will be affected to all the remaining threads also, as it is a shared variable. So total will be updated to 80. Okay, now let us say if T3 threads, if T3 thread has what, has got priority, and if it is executing, then it will execute the run method. No, so it will call the same run method, and it will say it is earth, and the withdrawal is 80. At the time the output will be, yeah, 80 is greater than or equal to 80, that means total is greater than or equal to withdrawal. And then you will print the statement earth has withdrawn 80 and total will be 0, right? Total equal to total minus withdrawal. Our total here is 80, 80 minus 80 is 0, that will be assigned to total. Now your total is 80. Now what is the leftover thread? That is T2. Now T2 will get chance, and then it will withdraw, it will try to withdraw 40, but at the other time withdrawal won't happen, because your total is 0 and this condition will fail. So it will go to the else part, and it will say moon cannot withdraw 40, and your current balance, it will show total, that is 0 at this time. So the thing is like, so yeah, okay, now we have taken the case of 132. Let us say the output is like 231. So 2 is like 40 and 80, right? And 1 is 20. That means I'm taking the amount. So 100 minus 40 is 60. So 60 you cannot withdraw here itself. So at that time you cannot withdraw. So it will go to the else part, and it will print it cannot withdraw 80, and the current balance is at the time it is 60. Okay, at the time it will be 60, and in the next run, what Sun is trying to withdraw 20. So yeah, your current balance is 60. Yeah, it will execute this statement. No, that time 60 is greater than or equal to 20, and you will get the print statement Sun has withdrawn whatever 20, and the current balance will be 60 minus 20 will be 40. That will be printed. So this order, like which thread is getting executed, we cannot predict, but the thing is like only two of them can withdraw the money, one cannot withdraw the money. Okay, you can see the output here. Okay, why this is not the possible case? Because your total is getting what changed in every thread, no? So you won't get, so you want total of 100, but how much you are trying to withdraw? It is like 140, no? So 140 you cannot withdraw. But if, yeah, that's why you are, this is not the output, this is not also output, because you are nowhere using what you are not illegal monitor state exception. When will you get? We have discussed this also. So when you try to use wait, notify, and notify, and notify all methods outside of the synchronized block, then you will get this exceptions, illegal monitor state exception. But you are not doing these things there, so that's why you won't get that exception here anywhere. Okay, okay, okay. Just I wanted to know, like, is it clear for everyone? Anyone has any doubt, you can ask. Yeah, is it clear or not?
Yes, ma'am. Yeah.
Yeah. Okay, yeah, okay. So what happens if it is not synchronized, if this method is not synchronized? What happens if this method is not synchronized? Like any one of you can answer, like what happens if the method is not, everything is same except that same.
Then only
Yeah,
second option will be correct.
What?
Then only the second option will be correct, because we are going one by one. So first the sun will go and withdraw 20, then moon will go and withdraw 40. Now we don't have any amount left, so Earth cannot withdraw anything.
no, not necessarily, because it will be interleaved, and that will cause a confusion. Like it will show errors.
Yeah.
A negative balance or something.
Yeah.
Mhm.
Yeah, yeah, you are correct. So the thing is like, so the one who has told why second option is correct. So what synchronize? What is the
Sorry,
purpose of?
okay, and renewable you are not moved. Okay, okay. It can be minus also.
Sorry. Okay, the what is I just wanted to tell what is like purpose of synchronization. So so now the thing is like, we are acting on the shared variable total. Shared variable total is a shared variable, right? So the three threads are is using the same variable, because you are passing the same object bank, same object obj, you are passing for both the for all the three threads. So that means this bank is shared. That is like this this instance variable total is shared variable between the three threads. So yeah, now okay, if the synchronized is not there, what is like what is the purpose of synchronize? It guarantees the mutual exclusion. Mutual exclusion means only one thread can operate on the critical session at a time. It guarantees the atomic operation. So I will write this mutual exclusion. I will write this. What is critical session? Critical session is the place where you are operating on the shared variables. So whatever the place you are operating on the shared variables, that is called the critical session. So you are operating on total here. That means here this is some kind of what you are decrementing here, no? So you are subtracting from the totally subtracting from this amount withdrawal. So you are operating on the shared variable total. So total is a shared variable. This session of the code is called critical session. Here you are operating on the shared variable. Okay. So what mutual exclusion guarantees you is means what does mutual exclusion means? So only one thread need to operate on this critical session. That means only one thread can operate on this critical session. Critical session is the code where the shared variables are, we are operating on the shared variables. So if we say this method is synchronized, that means only one thread at a time can use this extract method, can operate on this, can execute this extract method. No other thread can execute this extract method. So if T1 is executing this extract method, at the time no other thread can execute this extract method. But if you remove the synchronized word synchronized from here, if you remove the word synchronized from here, that means okay, if T1 has entered this extract, if T1 is executing this extract method, at that time T2 and T3 also can also what execute this extract method. At the same time, T2 and T3 also can act on this extract method even if T1 is operating. But if you say it is synchronized, and if T1 is operating on it, at that time T2 and T3 cannot execute those statements inside the synchronized block. Okay, we are now we have removed the synchronized keyword. No, now let us say T1 is doing this thing. Okay, now the total, anyhow total will be greater than 20. Okay, this statement will be executed. At the same time, if T2 is entering and if it is checking for this condition, at the time you have not subtracted withdrawal amount, like 100 minus 20 has not happened. Total is still 80 at that time, not 80. It's total is 100. It's still 100 at that time. Yeah, total can be still 100 at that time. Okay, T1 has executed only these two statements. So yeah, total has not decremented. So total will be still 100. So if T2 has entered this extract the extract block, at the time total will be like 100 only. It will say 100 is greater than 80. Okay, 100 is greater than 40 or something. Then it will execute this statement and it will withdraw. What it will try to withdraw. Okay, at the same time after withdrawal, like it will be balance will be 60. No, so yeah, this has happened. At the same time after doing this 60, if T3 has entered here, yeah, what will be the output here? So 60 is will be greater than or equal to 40. So you will, the thing is like three threads can operate, and you may withdraw all the amount. The sun can withdraw 80, sun can withdraw 20, the sun can withdraw 20, moon can withdraw 40, and it can withdraw 80 at the time. Because so before executing the statement, if the other threads has entered here and if they try to operate, they will see total is greater than withdrawal, and they also can happily withdraw the amount, and after that they can decrement the amount. So the thing is like you may get this kind of outputs. So the thing is like your account has 100 balance only, but you are able to withdraw 140 at the time, because this is not synchronized. That means many okay, let us see the case like okay, you have one single bank, but you have 3 ATM cards, and you gave the pin to 3 persons, and you have some balance of 1000. Let's take 1000. Okay, if all of the 3 members are trying to withdraw 1000 from the account, so yeah, like if they are trying to withdraw the amount 1000, yeah, they initially will see 1000, and they will try to withdraw the 1000 at that time simultaneously. Yeah, that time there is possibility, right? Three can operate at the same time, and they can withdraw the amount. But the thing is like there is only 3000, only 1000, but you are trying to withdraw, you can withdraw 3000 at the time. So this is not the required thing. That so the thing is like if T1, if one ATM card user is operating on this bank, at that time no others can operate on this bank account. That means no others cannot withdraw the amount. If you say, then they can operate, like they can withdraw the correctly, right? Without this data inconsistency, like without this kind of thing. Is it clear or not? This
You said about 3 people trying to withdraw 1,000 each when the bank has a balance of only 1,000.
Yeah, this is practically not possible. Okay,
My
this
question
is not
is, what is
okay.
the duration? What is the duration you are having in mind? Because there will be always a lapse of at least 1 second between the three. So when the second person goes after 1 second, automatically the balance will become zero. After that, the balance will reflect the first person's withdrawal of 1,000 when the second person goes after 1 second. So what is the time duration?
Yeah, the point is like you wanted to know like
So even without
T1.
synchronized, even without the word synchronized, I think uh, at least 1 second lapse will be there between the three people trying in 3 different places.
No, the thing is like you must know
One
this.
second, Nalini, sorry to
Yeah.
interrupt. So why do you say there is 1 second lapse? How do you ensure that?
No, I mean, see, 1 second, less than 1 second and all, nobody can assume, like, it's very difficult, like,
What
at
if
least
it happens at exactly the same time?
Yeah, the three threads can do at the same time. They can be at the statement at the same time. You should know this. Yeah.
Yeah, but that can be a loss to the bank. I understand. If 2 people does it, I think 2,000, I think there's a loss. But it's highly improbable. I can think of like same 1
Why
second,
do you say,
same.
see, why do you say it's improbable? Like, see, suppose there is a bank branch or whatever which has, say, 1 lakh customers, 2 lakh customers. I mean, especially during the monthly salary time, pension time, especially, right? I mean, the pensioners are the ones who generally try to access ATM. Others generally try for the digital transactions these days, right? So when all of these pensioners are trying to get the money starting from day 1 to day 5, like first 5 days of the month, why do you think it is highly improbable that people would access at the same time?
No, I mean, if you don't set a time limit like 1 second for this particular loop, then I think 1 second, less than 1 second, I don't think any machine like same moment. I don't know, man, whether it's likely possible. Like, is there any duration?
Like you are going to book a Tatkal ticket, right?
Yeah.
So exactly at 11 o'clock, how many people are sending the request at the same time? Maybe a lakh of people.
Yeah.
Then how it will be handled?
Okay, this banking also, withdrawal also is
Yeah,
similar
it's
to
absolutely possible. No,
yes.
Say your transaction maybe required a 5-second time. It's normally doesn't require, but say it may not be exactly time. It's maybe on the second, like the second two, somebody sending a request. You cannot say like I am doing my transaction for 5 seconds, so come after 5 seconds.
Okay,
so simultaneously means in between that 5-7, maybe a thousands of requests already arrived.
Yeah, I'm convinced with your that call example. Sorry.
Yeah. Okay. Okay, just see this question. Yeah. So you are create this extends thread, no? So you're just creating this object here. That means you are creating the object of thread here, and you're starting this. So if you start, this will run. But there is main thread also, that also can happen simultaneously, this one also. So what basically we are doing here is 0 to 5, 0 to 4 we are iterating, 0 to 4 we are iterating, and this is kind of Fibonacci only, Fibonacci series only, right? C equal to A plus B. Initially the value of A and B are 1, so C will be 2, and it will be like in the next iteration it will be C value will be 3, in the coming iteration it will be 5, in the coming iteration it will be 8. So there are like 0 1 2 3 4 5. So 0 1 2 3 4. So you need to write one more number, no? 5 plus 8 is 13. So the output, the value of C will be 13, right? Okay, that, let us say only if this run block is executing inside the run method, if this only this T thread is executing, then C will be like 13 at this time. and what yeah, a will be 5 or 8, but we are, the thing is like what we are trying to print here in this block in the main thread is like t dot c. Okay, t dot c is nothing but 13. If this t1, if this t thread has executed this statement, if the t thread has executed this run method, then finally the output will be 13. So finally output will be 13. So the thing is like this is kind of threads we are doing now, so we'll get the interleaved output. So what happens? Okay, now if you have reached this block, so you are saying t dot wait, as these are happening in an interleaved manner. After seeing this t dot wait, the first statement is t dot wait, right? So t dot wait, what it does, this block just it waits, right? But this thread will be running, right? So here this thread has suspended, this main thread has suspended. After seeing this wait statement, this main thread has suspended, and it is waiting, and it is in wait state, right? It is like wait means it is in like kind of blocked state. That means it has lost its lock even inside the synchronized thing. Sorry, I think this obj only, this t only, t has suspended and it has lost its lock inside this synchronized block. We have seen, no, what is the purpose of this wait? The way whenever we have, after seeing the wait statement inside any block, that particular thing will get suspended and it will be gone to block state. Block state means it has lost its lock. That means other things also, other threads also can operate on the synchronized block at that time. Like other objects also can take over this. Okay, that is a blocked statements, like it has lost its lock, other threads also can come and operate over this. So now it is like it has lost its lock, so at the time the only remaining thread is this one. So it will finish and this thread won't start, this whatever this thing won't start until and unless, that is t thread only won't start until and unless what, this after encountering this notify or notify all. So even, so the thing is like the output will be always 13 only, because even if this has started first, even this t dot start has happened first, so yeah, after finishing everything, output will be 30. If, okay, let us say if these are happening in an simultaneously, at the time also this is blocked, this t dot wait it has encountered, so it won't execute, this synchronized block won't get executed until someone has notified this. So the thing is like after it will get notified only after finishing this for loop, no? So at the time also output will be 13. Okay, in the both cases the output will be 13 only, even if it is, even if this block is, even the main thread is executing first and if this block is getting executed, the at the time also the output will be 13 only, because we are waiting here. It's like it is gone to wait state, so it won't get executed until the other thread, some other thread has notified it. Something must notify it. So yeah, the thing is the output will be always 13, even this has happened first, or if they are happening simultaneously also.
I have one question.
Sorry,
I
you have
one
one.
question.
Okay, yeah.
When you are writing this t dot star, okay, it will go and call this run method that is written as synchronized. So even if I am calling some other t dot star, it will not going to call. But when you are calling again synchronized t and you are writing t dot wait, this process will not get automatically stopped. Means what we are running in the loop, because we are stopping the same object, the t object, which is running in the other thread, right? Or I am
Yes. Yeah, just let me, I'm thinking. Okay, okay, you are saying t dot wait will suspend this whatever, this the current thread you are telling, no, this run method.
Yeah, because yeah. or due to synchronization?
No, synchronize is just synchronization over this object, and this object is synchronized. That means nothing can.
Or due to this synchronization, this T is still running, and once the T is getting free, then only it is going to the wait operator, and then it is firing the print. It is like that.
So sorry, I didn't get what you're telling.
No, you are telling the answer will be 13. I run the code, it is showing 13 only. That's correct. But my
Yeah.
question that when we are putting this T wait, and before that we return synchronized T, as already we have this synchronized, this is calling, as synchronized is there, that's why the T is waiting for the second one, synchronized T. That's why it is running the entire loop, and then only it will calling. Is it like
Yeah. Yeah. Yes. So actually, okay, if it has synchronized of this, so whatever this means, this the particular T only, the particular T. Yeah, that means nothing can what can call,
Nalini, I
nothing
think I
can
got
use
the
this
question.
object.
Just
Yeah,
can
nothing
can
can.
I tell
Yeah,
something?
you can say. Yeah.
Yeah, Mukesh, I'll give you a clue. You need to then just go through the code to understand. So basically, inside for your program, whatever the threads are there, so there are basically two waiting queue. It's not exactly one waiting. One waiting queue will be if you are waiting outside the synchronized block.
okay?
And another waiting queue, you are already in the synchronized block, but you have called a wait, right?
Okay.
So outside queue, if you are waiting, that means if it is like another thread is going out the synchronized block, you get a chance to get into. But if you're inside the synchronized block queue, in that case, you have to be notified to be go into the access. Right? Just keep in your mind there are two queues. It will solve your problem.
Yeah, got it, sir. Told. Yeah, thank you.
Okay.
Understood.
Sir, I couldn't get it, sir. Can you explain the flow of control, sir?
See, there are two queues. It's not one waiting queue. Right? Waiting queue in the sense there are, suppose a n number of threads are there, one currently executing, right? Rest of the threads are waiting. So it sometimes gives a feeling there is only one waiting queue. But you need to understand there are two waiting queue. When one waiting queue, if you are outside of the synchronized block, means you are not still into the synchronized block. You are waiting to get into the synchronized block. That's one waiting queue. Another waiting queue is you are already entered into the synchronized block, but you called for a wait. That means you have got access to the synchronized blocks, but you have put into the wait because somebody has to notify you, right? That's the point.
Okay.
You have to read the program thoroughly using two queues so that you can clarify. So remember, whenever you are having synchronize and wait and notify, once you are into the synchronize, from the outside waiting queue, you are already gone out of it because you got access to your critical section, right? Now inside the synchronized block, again you are made to wait, but you cannot go back to the previous because you are already into the synchronized block. So then you have to be placed into a different queue. That queue is for you're already inside the synchronized block, but you have intentionally called for the wait so that you'll get a notify and you'll go into and start accessing.
Okay. Okay. So,
yeah, thank you. Thank you, Nalini. Thank you.
Yeah, thanks, sir. Yeah, this is like same question which we have seen, like withdrawal thing, but we have done this using the re-entrant lock. So exactly the same thing, but we have done using the re-entrant lock. Okay. And so why this? So what guarantees us the mutual exclusion? Synchronize, by using the synchronize keyword, and also by using locks also we can do this. So mutual exclusion I have already discussed. Only like one thread can be in the critical session. Critical session is a code where we are trying to operate on the shared data. So yeah, we can use the synchronized using synchronized keyword, or by using the re-entrant lock, or by using the logs. So the same thing here, synchronized, which we have already seen here using the logs. The thing is like, okay, now you have created the object of the re-entrant log, and if you say, if some particular thread has seen the statement log dot, so let's take like T1 is executing this extract method, T1 is on this extract method, and after seeing this statement log dot log, that means until and unless it releases a log, like that means the T1 has logged, this thread has logged, that means until and unless this it unlocks, no one cannot operate all these things, all this, until and unless it unlocks, no one cannot operate all over these things, all over the statements. The thing is, the thread, this thread has logged, and until and unless it releases as the log, no one can operate uh, on this statements. So the same thing, the synchronized, if you say something is synchronized, like if the thread, if the thread is like, if T1 thread has encountered the synchronized method, if it is operating on the synchronized method, then no other threads can execute the statement inside the synchronized method, no, if T1 is operating on that. So same thing, if the thread has gone to the log state, until and unless it releases its log, no other thread can operate over this, or on the statements. Okay, here you can, the same, the output will be same, like whatever this output you have got using synchronized, that output will be the same. The thing is, yeah, it also guarantees a mutual exclusion. Only one thread, if it has gone, if the some thread has locked, only that thread can use those only the thread can operate on those statements, no other thread can what simultaneously do that, until and unless it unlocks, no other thread can operate on the statements. It is same kind of like synchronized early.
So
Yeah.
technically, there is no difference between this synchronized with this re-entrance lock, right?
Yeah, but the thing is, you can what this is called you can see here, you have already called a lock on this thread, no. So same way you can do multiple times, you can lock a thread multiple times.
Okay.
Yeah, that is like, so you cannot operate on this statements until and unless it releases the lock twice. So log dot unlock must happen twice. So it is called re-entrant lock, because a thread can lock itself again, even if it is locked, it can lock itself, like it can lock multiple times, like no limit. Okay, technically the thing is like, if that some thread is locked, only the thread can operate on this statements, like whatever the lock encoded in this lock and unlock, between unlock and lock. Yeah, until you do unlock, only the thread can use that code block, no other thread can operate on that. Thing is like that. If you have locked multiple times, you should unlock multiple times, that number of times. Okay. Yeah, just I have discussed in the previous session what is these three methods: interrupt, interrupted, is interrupted. Anyone wanted to wants to tell us like what does interrupt will do, what does interrupted will do? This is like is interrupted. Okay. Anyone like, This one I have already, like this all three methods, no, I have already discussed in the previous session. Okay, if I say t dot interrupt, the thread gets interrupted. This t thread will get interrupted. T dot interrupt. If I say t dot interrupted, t is like thread object. If I say t dot interrupted, that means it will, if the thread is in, if the t thread, if this t thread is interrupted, it will return true, and it will change the interrupted, this interrupt status to false. It also sets the flag, so it will return true if the thread is interrupted. It also change the interrupted status to like it will also change that variable which is interrupt status to false. Also it will return true if the thread is interrupted, and it will also set the flag to false after returning it to true. So is interrupted also will say whether thread is interrupted or not. Okay, if it is interrupted, it will return true, but it won't set the flag. It won't set the interrupt flag to false or anything. Here it will set the interrupt flag to false. If it is true, then it will set to false. If the interrupted status is false of this thread, if t is not interrupted, if this thread is not interrupted, if you call t dot interrupted, then it will return false, and it will set the interrupt status to true. So it will change the status also. But is interrupted method, it will just tell whether thread is interrupted. If it is interrupted, it will return true. If it is not interrupted, it will return false. That's all. So you can, I think now you can answer this question. Okay. So now
True should be the answer.
Yeah, true should be the answer. You won't get infinite also. Sorry, you won't get infinite also as well, right? Because so yeah, the t is nothing but current thread. You are saying interrupt. That means interrupt status will be set to true at that time, and you are telling thread dot interrupted. So thread dot interrupted will return true. It will return true. It will print true, no? It will
Yeah.
interrupt status is true, and it will set interrupt status to false also.
Doubt. No, the syntax for interrupted is thread dot interrupted.
Yeah, sorry, I
dot
think thread dot interrupted because this is static method. Yeah,
static method. Okay.
yeah, this is instant, like general method. Yeah, instant.
Okay.
Yeah. So t dot is interrupted. At that time, it will check the status of the interrupt status. No, it will be false. So it won't go inside the for loop. So you will get only true as output. Okay. 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 So T1 is nothing but your main thread only, and inside that you have created object of map, IC map, that is like linked hash map. So it preserves the order of the inserted elements. So first you have created two strings array, and you are just putting the values. No, here you are iterating over this also has three elements, this also has three elements, and you are iterating over this arrays, and you are putting values now. So how the mapping will happen, a will be mapped to 1, and yeah, because you are using index, no, a will be mapped to 1, and b will be mapped to 2, and c will be mapped to 3. That this is your IC map. Okay, Now here you have created this thread object PLR test, that is T1, and you have passed this map to that, and you are telling T2 dot start. That means this thread can start, or else it can execute. The main thread can execute this statement before executing the run method. Main thread can execute this statement. What is T2? The next statement is like T2 dot join. So join method also we have discussed in the previous class. What does T dot join will do? So where you are seeing this T dot join, you're seeing in the main thread, no? So this main thread will wait until T has finished its execution. That is like T has finished the execution of the run method. After returning from, like, the main thread will not execute anything. It will stop there. It will wait for T to complete. Then only after returning from the run method, but like T should complete execution of this run method, then only this main thread will execute the further statement. That means this main thread is waiting for T2 to finish here. So main thread will wait for T2 to finish here. So so here you are inserting the value here. So now the map will become D is to 4 after seeing this statement. Now your IC map will be your map will be updated. Now that means this key D and value 4 will be inserted here in your map. Now here you are just iterating over your map, and you are printing the what value m dot get key. It will give a b, like in each iteration it will give keys, like it is the order is preserved. So you will get a, and the value will be like separated by this arrow, and then you will get the value, it will be 1. So the thing is like because of the join method, you are getting this kind of output a, b, c and d. Then the output will be a, b, c, d. But let's take, okay, let us take, if this join method is not there inside in the main thread, if this join method is not there, then what will happen? Okay, let us take, if this join method is not there in the main thread, then the statement is not there in the main thread, then
it can be only printed up to C, or it can be T.
Yeah.
Both
Yes.
options can be
Yeah.
there.
Yeah. Yes. So now, yeah, T dot start will happen. It doesn't guarantee, like we don't know whether this is happening first or this is happening first. We don't know. So yeah, if this is happening first, then you will get only ABC. Okay. Okay. If at least if this is happening entry set, if you are already getting entry set, then yeah, you will get only ABC. But if this is happening after this, if this is happening, then you will get ABC D. If run method is happening first, if this statement is happening first, then you will get ABCD. But if this is happening first, then you will get only ABC. That's all. If join method is not, if this T2 dot join statement is not there.
You said linked hash thing will preserve the linked hash map will preserve the order.
It will preserve the inserted order of the elements in the way in which you have entered. Here first I am entering A, B, C, then D, so it will preserve that order.
So my question with that order. My question is, when the T2 dot join is not there, we don't know that that the list has only 3 elements A, B, C.
Yes.
So we don't know whether that run will happen or not after this. So that particular set will have only 3 elements A, B, C.
Yes. Yeah. Yeah.
But if run is happening, suppose for instance run in one case run is happening first, then the order will become then the set will be raised to 4 elements now, which it will contain D, A, B, C. So that also can be a possibility.
No, it will preserve the insertion order. So what is the first element inserted here? A. Second element is B. Third element is C, and the last element is D. It's fourth. Like
my question, if run is happening,
yeah, run is happening
even without the T2 dot join statement not there in that. If the run is happening first, then where will that D get appended in that?
D will be appended last. Already you have inserted ABC here itself, no? Already you have inserted ABC here itself.
Okay.
Yeah.
In that loop only.
Yeah.
Okay.
Here in the loop itself, you have inserted ABC. Here now you are just printing those things, elements. It is like if T2 dot join is not there, you will get only ABC. If it is there, insertion will happen and then ABCD will be printed now. Yeah. Okay. Okay, I think, yeah, I think this is the same thing which we have seen, but without having join here. Without having join statement is the same thing, I think. Yeah. So yeah, output we have already discussed. No, it will be either what, I think something different is there here. Okay, let's see. It is linked hash map. Okay, now ABC and it is linked hash map only. Okay, you are the order will be like int I equal to 0 to I less than string dot length. Okay, you are iterating and you are putting those values inside your map, and then okay, then you are what? Okay, what is the output? Which of the following is not true statement? No, here. So the output can be ABC, this 1 2 3 1 2 3 4, it can be. And here the this output you won't get, no, because order is preserved in your linked hash map, so it will be always D equal to 4. That can happen. So D equal to 4 won't happen. The thing is like not possible output. Okay. This is same as the previous question which we discussed without join statement, and the output will be 1 2 3 1 2 3 4, which we have already discussed. This won't happen. That's why you will get this as answer. The question is not true. Okay.
Without that T2 dot join, in this particular there is no join statement, then in which part of the code is the D getting inserted? As the last element.
This if T dot, sorry, you are saying this is not possible output. This is not possible output.
Not
okay.
This one, the previous one. Why is it possible? That ABCD.
ABCD. Okay. If T dot start is happening first before printing the values, if T dot start is happening first, that means the run method is getting executed before executing these statements. Before executing these statements, if run is happening, then your map is getting updated. No, you are putting, so you are passing some map object, and this is like you are putting value to D is to 4, like that
then,
is happening.
Then in the previous case also, previous problem when we discussed about the T2 dot join statement not there, you just talked with only ABC. There the possibility is ABCD also is also possible. No?
Yes, yeah, there also
T2 dot
ABCD.
join.
Yeah, this is the output. No, this is like a ABCD is also.
It's also possible for the previous problem.
Yeah, I told like there will be possible two outputs, ABC or ABCD. If this is happening first, then you will get ABCD. If this is happening first, I told it is ABC only.
Okay.
Ma'am, I have a doubt, like concurrent modification exception.
Yeah, I will come to that. Okay. Okay. You want like when concurrent modification exception will come. Okay, now I have two threads, T1, T2. And this is operating on some map object M1. This is also operating on the same map object M1. Okay, yeah. Now, yeah, inside the run method, okay, let's take inside this run method, you are trying to update your map. Okay, you are trying to update your map. Like, yeah, and also you are trying to print that map. you're trying to update and if you're trying to print that map. So this map, same map, you are trying to update, you are printing using T1 and T2. You are saying T1 dot start and T2 dot start. And if this is not synchronized, then two can operate on this map simultaneously. Okay. If T1 is updating, if T2 is printing, no issue. Okay, but if T2 is updating, if T2 is updating and if T1 is printing, no issue. But if T1 and T2 are updating what if T1 and T2, if T1 is inserting some value to this what map M1, and at the same time if T2 is trying to get the entry dot key set, that key set if it is trying to get, if it is updating the same M1, and at the same time if T2 is trying to get trying to get the entry set, at the time you will get concurrent modification exception, because you are putting and if you are trying to get the map now at the same time. So at that time you will get concurrent modification exception. So previously we have seen if multiple users are trying to book some ticket at the same time, same thing. If you are trying to put and if you are trying to print at the same time, like T1 is trying to put and T2 is trying to print, like trying to get the entry set at the same time, that time you will get concurrent modification exception, because that entry set will get modified, no, if you are if you put that. But here you are doing the same thing at the same time, you are doing two things at the same time on the same map, so you will get this concurrent modification exception.
In question 8, ma'am, we don't declare the main method as a thread. Still, will it work like that?
Yeah, still, yeah, actually, so every time you are seeing no main, inside the main, if you have two thread T1 dot start and T2 dot start, T2 dot start, that means this will start the, like it will execute, this also can execute, and the main will also be executing the some statements, no, here some statements it will have, no. So the thing is like main will do its work. So after doing its T1, after it will start T1, it will start T2, and main has some more work to do, right? So it is also kind of different thread only at the time. So every time after starting T1 or T2 or something, if main has few more statements to execute, it will start executing its statements. Yeah. Okay, that is also kind of thread only.
Because in question 7, we declare this current thread. Okay. Like
which one?
In the main method in F class.
Yeah, thread dot current thread. Yes.
Yeah, we declare it as a thread and we go about doing it. Okay. But in the question 8, we don't have that statement.
Yeah, like
still it would behave like that.
So okay, we'll see what we are doing here. T1, we are not using T1 at anywhere, no, here T1 dot start or something, nothing is there, no, here.
Yeah.
But the thing is like T1 also, the thing is like T1 is like main thread, T1 is like main thread, it would also will execute this map, this whatever the statements which are present after this statement. So the thing is why they have used is like T2, this T1 will wait for T2 to join, like for T2 to finish the execution. That's all. Okay, we are not using this T1 anywhere. Okay, the thing is like T1 will also act as a thread.
And when we don't use a particular variable or something, then Java will say like it's not being used anywhere in the program. So such an error, the compiler, like you cannot
for variables you won't get error. You won't get error if some variable is not used. You won't get error if
some later in
code.
The program. Now you have declared T1. So
you won't get error. When you will get error is if some part of the code is unreached, so you are not using that code anywhere. So main method will always execute this code block. So okay, you have something which is unreached. That means if you are not executing that at any time, that code block, then you will get, at the time you will get error. That particular code block is unreached, you will get some error like that. Okay,
So we can write any number of statements like this thread T1 because T1 has not been used anywhere. So
Yeah,
it will not cause a problem.
yeah. Okay, you can write int x equal to some 10 without using it inside the main. Okay, you can do that. Okay, the thing is like unreached code. If there is some unreached code, at that time you will get error. Unreached code means, yeah,
Already you have declared, but that the method as you have not written something like
see, still
it's
in the
not able to
classes,
reach to that.
okay, you have some class, you will have class, no, in that class you will have many methods, but still without using that methods, without calling the methods, you won't get error at that time, because you can say t dot some whatever obj dot that extract or any method you can call. But something like unreached method means like anything cannot reach that, you cannot reach that code block using anything, something like that. Yeah, I think we should search this for
Okay.
now. I'm not getting the examples. You can search unreached code blocks,
Yeah.
examples of
No
unreached
problem.
code blocks. Yeah.
Thank you.
Okay, I will say thread states first. I will discuss the thread states first and then we'll go through this problem. Previously also we have discussed this. If you say thread t1 equal to new thread, that means this thread is, this t1 thread is in new state. It has just created. Okay, it has just created. If you say t dot start, t1 dot start, here I use t1, no, t1 dot start, that means it is in runnable state. That means you can at any time, like OS, it is depends on OS, no, at any time OS can give priority to it and it can execute the run method. So it is in runnable state. It means like, it mean, so it need not be running at the time. That means run whatever the statements which are present inside the run block, run method, those might not be, they are not executing at the time. That means it is just ready to run state. That means at any time the OS can give priority to it and it can run, it can start executing the run method. But what is meant running means the thread is actually executing the statements which are present inside the run method. Okay, start has happened and also it is executing the whatever the statements which are present inside the run method. Running means, runnable means it is ready to run, it is not actually running. Okay, now you have timed waiting. Timed waiting means the thread is, the example is sleep. You can say t if thread dot sleep of 100 milliseconds, that means thread will sleep for that particular amount of time. At that time we can say thread is like in the timed waiting state, it is waiting for this 100 milliseconds to finish. Okay, that is timed waiting state. And okay, and there is something called blocked state. Blocked state means, okay, thread has started already running, but thread has already started running, but it has it, okay, something, but inside the thread you might have seen wait method. That means, okay, thread will stop its execution and it will go to blocked state. Blocked state means the thread will release its lock and it will give opportunity to other threads to run. Okay, it will release its lock, a log. The wait statements, when can you use? Only inside the synchronized blocks. You can use only the synchronized block, this wait statement. Okay, then there is termination. Termination means thread has finished his execution, run method has finished or it has stopped, the thread working has stopped. So it can stop, no, like if it has got some exception like interrupted exception or illegal monitor state exception, the thread will terminate, no, that is like termination. So it has new, runnable, running, timed waiting, blocked and terminate. So new means thread is actually, we have created the thread. Runnable means thread is ready to run, and running means thread is actually executing the statements which are present inside the run method. And time waiting means it is waiting for some condition to happen, or is waiting for some particular amount of time. Okay. Block means thread has gone to, like, thread is actually running, it has acquired some, it is actually in the runnable state, but it has, like, it has gone to the block statements, like it has suspended its execution, it has gone to the waiting state. That means the runnable thread, like the thread which has already run only can go into the blocked state, no, because it has already reached the runnable state, but somehow after seeing wait or some condition, it will go to the internal queue and it will wait for some condition to happen, then it can again start executing the thread. That means this is blocked state. And this is termination. There's like two kinds of termination, like normal termination after executing the statement inside the run method, that means normal termination happens. But if it has encountered some exception, it will, yeah, exception or some kind of, yeah, at the time the thread will terminate, no? This is like thread states. Okay, now in the following program there are two user defined threads named Dijkstra and Turing. Okay, the program prints the different possible thread states that each of the threads can be in during the execution of the program. So it generally prints these two thread states. Now inside the main method we have two threads, T1 and T2, and one is this Dijkstra's and another is like Turing. And if you say thread dot current thread dot set, okay, this is nothing important here. Okay, system dot outer println, and you are calling before calling start. Okay, you are saying before calling the start method what will be the state of this thread. So you can get the state of this thread by saying t dot gets state. So t dot get state, what will be the state of the thread at this time before calling start method. What state t1 will be before calling this start method? New. Okay, new. You are just printing the thread state here. You are just appending the line Dijkstra's before calling start is new. Okay, same. Turing before calling start is new, because both we have not called t dot start, t1 dot start we have not done, no, and t2 dot start also we have not done. So both will be in the new state only. So after t1 dot start and t2 dot start we have done. So what will be the state here? Both will be in the runnable state. We don't know whether it will be runnable or running. We don't know that. We don't know here. Okay, here we are saying thread dot sleep of 200 milliseconds. That means
Blocked.
Timed wait.
yeah, it will be in the okay, a
Time
thread remains in the time and wait when it is sleeping. Okay, a thread remains in the time and wait when it is sleeping. A thread is in the blocked state when it is waiting for the object lock to be released by some other object which is using that object. So it is already running, but after seeing some condition or something, it has gone to, it will be waiting in the internal queue for some condition, for some other thread to notify it. So that means it will be in the blocked state. That is called blocked state. So it has already acquired the lock, it is already running, it will be already acquired the lock, but it will be waiting for some other condition to happen, for some other thread to notify. That means this. Okay, what will be the state of this t1 dot get state after seeing the sleep statement? Okay, what will happen inside the start? Okay, this sleep is, after seeing the sleep, this they won't go into this timed waiting state, because this sleep statement is for only the main thread, no, because you are seeing this inside the main block, main thing. But when this t1 and t2 will go to this timed wait state when it has encountered sleep statement while it is running. So okay, let's take here. Okay, they have gone to this method, this inside the run method, and after seeing this sleep thread dot sleep. After seeing this, then at the time they can be in what time waiting state. Okay. Okay, T1 dot join and T2 dot join will wait for those threads to finish. This main method will wait for T1 to finish and for T2 to finish. And then if you are getting the state, it will be terminated. No, they will get terminated, right? And everything will be stopped and they will be terminated. T1 and T2 will be terminated by the time. Okay, you can see the code block here. So yeah, you will get this statements, no, while you are executing the run method, you will get this statement, no, because T1 and T2 both will enter this run method and both will finish the execution. Then only you are taking the state. At that time, before that, they will execute the statement. Here you will see Turing thread dot current thread. It will give the instance of that whatever thread which is running, and dot get name will give that name of the thread. So if it is Turing thread is running this, it will give Turing is inside this run method, but not sleeping. Okay. So that is the thing. You won't get blocked state anywhere because you have not seen such kind of cases, no wait or anything like that. Yeah, blocked won't be there. Blocked you won't see here. Okay, we'll just read the solution also once. That is in the time waiting state when it is sleeping. The only part of the code where either the Turing or can execute the thread or sleep instruction is inside the run method. Okay. Now in the first option, both the threads are together in the timed waiting state, which means both have been inside the run method together and its mutual exclusion could not be achieved. But run method is synchronized in this example, and hence it must guarantee mutual exclusion on its thread state. Thus we reach the contradiction which clearly indicates that the output given in option 1 can never whether our run method is synchronized. Actually I have seen, yeah, I have not seen this. The thing is, like, our run method is synchronized. If T1 is executing this run method, T2 won't be like gaining its thing. Okay, gaining this thing. Okay, let's take T1 dot start has happened, T2 dot start also has happened. So that means it will be in the runnable state and you are just making it main thread to sleep. Okay, at the time thread dot sleep will happen if T1 is executing, so it will be in the timed waiting state. Okay, if okay, it will be in the timed waiting state at that time. Yeah. And after that, it will execute this statement only. So after sleeping, it will execute this statement only. Okay, at the time, yeah, if T2 is trying to access that thread, you won't get access to that. Okay, I think you will understand this question if you just understand what thread states completely. Then
Just one question. When we are calling this v1 dot start, it will, as it is a synchronized, that we know that T2 will not call. But this thread dot sleep, it will reach to that section, because thread is also something we are calling it, right? So this thread dot sleep will not call until this T2 will complete. Is it correct?
no. So the thing is, we have already seen, no. So now here we have 3 threads. One is T1, other is T2, and other one is main thread.
Right.
Okay, yeah. Now the thing is, like, T1 and T2 should execute the run method, right? Should execute the run method. If T1 is running, T2 won't run
Right.
because it is synchronized. Okay,
Right.
yeah. So if t1 is, t2 is not won't run, but main thread will execute these statements. It has nothing to do with the run method, so it will just execute the statements which are present here under, like after this also. So the thing is like, okay, now you have three threads, t1, t2 and t3. T3 is main thread, so the execution can be like main thread will be running, or t1 can be running, or t2 can be running. If t2 is running, t1 won't be running, but t3 has no, can run. Even if t1 is running or t2 is running, t3 can run. The thing is, it has nothing to do with the run method. It will do its own job. It will execute the statements which are present under the thread, right, until and unless it sees this join statement. If it has seen the join statement, it will wait for t1 and t2 to finish. Okay.
Right, right. So this before joining, that T1 dot get status can be runnable, right? Because thread dot sleep doesn't depend upon T1 and T2, right? So this can be also sometime runnable, right?
Yeah, this can also be
Runnable.
this can also be runnable sometimes, yes.
So
At
in
that
some
time.
cases it can show this is running, but not sleeping method. Okay.
Mm.
Thank you.
Okay, yeah, if you have any doubt in the AQ or anything, you can ask. Anyone, if you have any doubt in the AQ or anything, you can ask. No doubts in this week 11 concepts. uh, yeah, should I discuss AQ, or yeah, if I start discussing AQ, it won't be finished. But if you have any doubt, you can just ask. Um, okay, we'll take this AQ question and we'll discuss for this 15 minutes. Just a minute.
I think you are in mute, ma'am.
Okay. Yes, sorry. Yeah. Okay, sorry. Yeah, the thing is like, we have this three different book ticket objects, and yeah, three different, no, obj1, obj2 and obj3, because there are three different book ticket object. And you have t1, t2 and t3. There you are passing three different passengers, and to three different passengers you are passing obj, obj1 and obj2 with different name and different number of tickets to be booked. Sun 2 1. Okay, that's all. And then you are starting this all three threads simultaneously. Okay. uh, yeah, if you start, yeah, they will execute like either t1 or t2 or t3. They can go into the run method and can execute the statement obj dot. If t1 is going, then it will say like obj dot extract of name comma, that means sun and 2. Extract method, what is there? Sun comma 2, right? Sun and 2. So yeah, available tickets are 3. And you should remember, like, this block is synchronized and this is a static variable. Static variable means, so yeah, so if it is changed, if this if the variable, if the available, the whatever the value of the available, if that variable gets changed, that will be reflected in all the 3 threads, no? Because this is static variable. Even if the objects are different, like now you have 3 different book objects, no? Obj, obj1 and obj2. Even the objects are different, but as this variable is static, the value, if the available value is changed, that will be reflected in all the 3 threads, because that is static, the available way. Yeah. So now, sorry, yeah, so now the what book is 2 is less than or equal to 3, then you will get sun booked 2 tickets you will get, and available equal to available minus book will happen. That means 3 minus 2, it will be 1 ticket only. Next, let's take if next T2 is going, that is moon is going to execute the extract statement, it will still find. Yeah, I'm saying after T1 only T2 enters, because this block is synchronized. After T1 only T2 will enter. T2 won't enter this extract block in between. Okay. So at the time the book will be like 1, and it is also less than or equal to 1. Available is also 1. So moon will also book 1 ticket. Uh, okay. Earth can't book tickets, no, because available count is 0 at this time, because available minus book will happen, it will be 0. So it will go to the else part and it will execute the statement. Okay, the thing is, the important thing is, even if the block is synchronized, if the variable is not static, you may book ticket to, you can book ticket to all the other object, all the sun, moon and earth also can book tickets at that time, no? Because okay, let's remove static from here. Let's remove static, because you have 3 different book ticket objects and the available is 3, and whatever here you are using sun, moon and earth, here they're trying to book to 1 and 2, that is less than 3. So you have here 3 different book ticket objects. So sun will have 3, moon also will have 3 and earth also will have 3. So at that time your output will be all can book tickets. But as this variable is static, that means it is shared variable between the 3, like whatever the change you have done in like obj1 or obj2 of this book ticket object, it is going to reflect the remaining objects also. So yeah, so you can book only output varies, no? You can book at the time to sun, moon and earth might not be booked, so you can book earth and moon at the time sun cannot book. This happens. Thing is, you should know this. Okay, which will be the possible output? The question is like possible, so it is like, so this won't happen. All the 3 won't get tickets, because you have 3 tickets, but you are trying to what you are trying to book 5 tickets, so it won't get. And this program won't generate interrupted and illegal monitor state exception, because thread dot sleep or wait or notify, nothing is there, so you won't get such kind of exceptions here. You are not interrupting also, that's why. Yeah, so the possible output is this one. Okay, is this clear?
Yes, clear.
Okay, yeah, this question will, okay, here itself you have main method, no? Now you have this scanner, and in this test class you have scanner and printer object, those are static. Both are static. Okay, and you have this desktop and laptop, they are thread, they are like runnable, so you can make them as threads, and you are starting those runnable these things, desktop and laptop. Okay, the possibility is like, let us take like they can do in an synchronized, like interleaved manner, like T1 can go or T2 can go, something like that. That order cannot be we cannot predict the order. So let's take just this T1 is getting executed. That means laptop, or not, that means desktop, not D, no. And desktop is going here. So that means this done. This scanner is synchronized. Scanner is synchronized means at this time, uh, yeah, at this time, what laptop or any other thread cannot use scanner. Scanner is synchronized. That means only uh, scanner is synchronized means laptop cannot use the scanner as desktop is using. No, this time this is synchronized, so you will get the output as desktop scanner busy if T1 is going first. Okay, they will happen in interleaved manner, no. So you can get simultaneously this printer is synchronized here, so you will get laptop printer busy also. You can get this output also. Okay, this try catch nothing. Sleep, you are making it to sleep for this 1 nanosecond. Okay, yeah, and then you are seeing the statement desktop waiting for printer. You can get this statement, but if you call synchronized printer, you won't see. If this laptop has acquired the printer, if this laptop has acquired the printer, you won't get, you cannot use printer here, no. That's why this statement won't get executed. Yeah, similarly here also you are trying to use the scanner inside the what laptop, which is already acquired by the desktop. So this statement you won't get this. That means here scanner is acquired by this desktop. At the same time, if the printer is acquired by the laptop, then if you try to use a printer and scanner, you won't, you cannot use until this see, the scanner cannot be used by the other object until and unless the synchronized block is finished. So this synchronized block is finishing here only, no. So till that time you cannot do. Same here also, the printer cannot be used by desktop until and unless it has released that printer. So it will be happening at the end only. Meanwhile this desktop is waiting for scanner and laptop is waiting for desktop is waiting for printer and laptop is waiting for scanner. So you will get kind of deadlock, no. That means, so yeah, printer is not released by this laptop and scanner is not released by the desktop, but still laptop wants the scanner and desktop want printer. So yeah, the thing is like, okay, T1 and T2 you have, and now T1 has scanner inside it. Okay, it is calling printer. It is calling for printer. It is looking for printer. Okay, but printer is with T2. But printer is with T2 and scanner is with T1. It is looking for print. It is waiting for what scanner. It wants scanner. But it is not releasing printer, it is also not releasing scanner. So it will kind of deadlock, no. Both are what, both wanted the resource, but it is not available for them. This also want resource, this also want some resource. This printer resource it wants scanner resource, but it is with someone. So yeah, that time it will kind of deadlock, right? Yeah, the program will execute the statements, these statements like scanner busy, printer busy, these statements it will execute. But the thing is like without any deadlock is wrong, but there will be a deadlock, no, that printer is waiting for what laptop is waiting for scanner and desktop is waiting for printer. So you will get, there will be kind of deadlock. So I think you should read this solution also. We just will read this program. One thread acquires a lock of printer and the other acquires a lock of scanner. Okay, printer is with laptop, no. Printer is with laptop. Here synchronized printer, that means laptop has acquired the printer lock. Okay, lock of printer and the other acquires the scanner lock. To release the respective lock, to the whole synchronized block need to be executed. Yeah, they should finish the synchronized block, then only that scanner will be released or printer will be released. The problem here is that the thread which locks the printer also expects the scanner and lock and vice versa. Okay, hence neither of the synchronized block gets fully executed and the result, none of the locks will be releasing in a deadlock condition. Is it clear?
What is sleep 0, 1?
Sorry, what is?
There's sleep 0, 1.
Yeah, sleep has two, like you can sleep, one kind of sleep will take milliseconds. So yeah, sleep, it will be long milliseconds. Another kind of sleep will take like two, it is overloaded. So it will have long milliseconds and in nanoseconds. Okay.
Okay.
Yeah. Okay, we'll what finish this question, and I think we can what finish the session. But the thing is, the thing is the threads, you should what execute, then only you will understand and you will get the doubts. If I just explain, no, you won't get much. Okay, but we'll see this question and we'll finish. Okay. Okay, now you have total object, and now ticket. For the ticket object, ticket class, for the ticket thread, you are passing this total earn, and then you are starting. Okay. And okay, if this object is synchronized and you're saying object dot wait and object dot, okay, we'll see this run method. Inside the run method, what you are telling, you are calling calculate of number comma sum. So calculate will say what it will do. Okay, so this is similar to the question which you have seen also, no? Synchronized what Fibonacci we have seen, no? That like we are printing the Fibonacci in one side and the other side there is synchronized. The same thing here also. So sum will be like 0 to n, no? So n is like 10 and price is 5. So it will be sum plus, so it will be 50, no? 10 into 5 only, right? 50. That means the loop is running from what 0 to 9, that means 10 times, and every time 5 is getting added, that is 10 into that is like 10, 5 is getting added 10 times. You will get 50 only, no? Yeah, you will get 50 only, right? Okay, yeah, you will the thing is like if it has started first and if it has finished, then you will get here 50, the sum will be 50, and if you try to print, it will be 50 here. But before that, if main is executing and it has acquired this synchronized block, and if you say object dot wait of 100 milliseconds, this will wait, but still this will run the synchronization, this will happen, t dot start, this already will happen, and still you will get this what 100, and you will notify, and if after notifying this dot notify, after seeing notify all, it will release it will go into the runnable state, and then what after releasing this, it can execute the statement on this object. So obj.sum will happen, so 50 will be printed. This is similar to the thing which you have seen in the Fibonacci question. Okay, just we'll see this one also. This is like kind of easy only, I think. Okay, this is using the re-entrant log. You have same demo log as what object. You are passing that to 3 threads. That means this is obj is shared between the 3 threads. E1, E2 and E3 is sharing the obj object. So obj, inside the obj object, you are calling the display sun or moon or anything earth. So yeah, but the thing is, if sun has acquired this display method, then it is locked 2 times. No, it is locked 2 times. That means only sun can use this display method if it is sun is happening. So output will be uh, uh, output will be 1. In the first iteration it will be 1 is to sun, in the second iteration it will be 2 is to sun, in the third iteration it will be 3 is to sun. Space is separated by space, no? and then you have new line. So the loop won't execute for the fourth time, and then it will unlock, but it should be unlocked twice because it has acquired the lock twice. It should be unlocked twice, but we are unlocking only once. So no other thread will get chance to run this execute this display method because it has unlocked only once. So whatever the thread which has initially got acquired this display method, if T1 has acquired this lock of this method, then only sun will be printed. If T2 has acquired, then moon will be printed. If T3 has acquired, then what earth will be printed. But only one thing will be printed, either sun or moon or earth. But all the three won't be printed because lock is not unlocked. The first one, which is executing the display method, is released only once. No, the other threads won't get chance to acquire this to execute the display method because it is locked. It has released only once. That's why the other threads won't execute, so the output won't be so you won't get this kind of output. Yeah, you won't get this kind of output also because yeah, inside the iteration only sun is iterating. No other threads cannot come because it is locked. So you will get only sun. Even if it is like, okay, here sun is not there, only moon, same thing, 2 moon or 3 moon, if it is there, this also will be correct. The same thing, if instead of moon, if earth is there, it will be also correct thing, but 3 won't happen. The thing is because it is not releasing the lock. No, that's why. Is it clear, this question?
Yes, clear. But it will not throw the compiler, right? Even we are not writing 2 times lock.
Yeah, it won't. There is no such kind of exception.
Okay.
Yeah. Okay. Here also, this is simple whole lock count only. Re-entrant lock, you are locking it once, no? Inside the main method, you are creating the object of lock and you are locking once. And then you are checking is locked. You will get true only, no? Is locked will be true, and followed by space. You will have space, and then you are trying to print the get hold count. Lock.get hold count will give like number of times this has locked, this has got locked. So it is like one only, no, at that time, at this time. And after seeing this log, the second time it will be 2, right? Get log dot hold count, it will be 2, and after seeing the third time it will be 3. And this your unlock is okay, here you are doing unlock, so lock count will be reduced by, will be decreased, no? So if you do this, you will get log dot hold count, you will get 1 here. So first time it will be 1 in here, second time 2, and it will be 1 again because you are unlocking here, and here it will be locked only, no, because it has acquired lock twice, but you have released once only. So yeah, it is still locked, so lock is locked will be true. Okay. Yeah, is this clear?
Yes, clear.
Okay, I think okay, from 11.2 I think you can try yourself. If you have any doubts, we can solve in the next sessions. Okay, coming session from 11.2. Okay, yeah, because this is like kind of, if you do, then only you will get some clarity, no? You should try yourself. Okay. Yeah, from 11.2 we can if you have any doubt, we can solve in the next session if you ask. Okay. Yeah, yes ma'am, can we? Yeah, I think we can close end the session.
Thank you.
Yeah.
Thank you.
Thank you.